Okay, we're going to put everything we know together to help us graph this rational function properly. First thing I'm going to do is talk about the horizontal and vertical asymptotes. Let's start with the vertical asymptote. Notice that this fraction, or this rational function, cannot be factored in the top nor in the bottom, so this cannot be reduced. Which means, if we look at our denominator, we know back from our domain issue that x minus 1 cannot equal 0, x cannot equal positive 1. That's going to give us our vertical asymptote. Since it can't be there, that's going to be my boundary. X equals positive 1 is a vertical asymptote. Then I'm going to look at my horizontal asymptote. I notice that my numerator is a first degree Pauli. My denominator is a first degree Pauli. That tells me that I'm going to have a horizontal asymptote at y equals, I'm going to find the numerator of this fraction from my lead coefficient on top and the denominator from my lead coefficient on bottom. So I have a horizontal asymptote at y equals 1. Now, let's take a look at what I have so far. At x equals 1, I have a vertical asymptote. At y equals 1, I have a horizontal asymptote. I'm going to bring my calculator in, plug in y equals, and plug in the formula x plus 2 quantity divided by the quantity x plus 1, x minus 1. I'm going to go ahead and do a zoom standard. That's going to take me from negative 10 to positive 10 on the x values, negative 10 to positive 10 on the y values. Notice the shape of my graph. Starting over here, I know that I'm getting very, very close but not reaching that asymptote, and same over here. Also, I'm coming down somewhere around here and approaching my vertical asymptote, and I'm going to rise up and approach my horizontal asymptote. By knowing the locations of my asymptote, I already started off with a reasonable location to look for my graph. Okay, we're given f of x equals the rational function 10x plus 1 divided by the quantity x plus 1. And this can be used to model an insect population in millions where x is greater than or equal to 0 is in months. First objective, we're going to determine the initial insect population. What do I mean by the initial insect population? Well, what is the population at the very beginning, which would be 0 months? I'm going to find that by plugging in 0 into my formula. I'm going to simplify. And now I'm going to interpret what I have found. That at the very beginning, my insect population was 1 million insects. Because x is 0, y is 1, where my input is months. So the beginning is 0 months, and my output is the population in millions. Part B. We want to determine what happens to the population over time. Question? Well, let's think about it. What do I mean, what happens to the population over time? What I'm really talking about as I go further and further and further out for x. Another way of looking at that is as x goes to positive infinity as I'm going out to the right. Well, notice, if I go to the original function, my top is a first degree polynomial. My bottom is also a first degree polynomial. That means I have a horizontal asymptote. I can calculate that horizontal asymptote at y equals my lead coefficients numerator over my lead coefficient in the denominator. This tells me that the graph has a horizontal asymptote at 10, which means my output is getting closer and closer to 10. This leads me to conclude that as x gets bigger and bigger, y is going to get closer and closer to 10. Y is my insect population, which tells me that the insect population should be approaching 10 million. Let's take a look at that on a graph. First thing I'm going to do is go ahead and plug in the formula. Parentheses 10x plus 1 divided by x plus 1. I'm going to start with a zoom standard to begin with. Oh, I need a parentheses in there. Little bit difficult to see, so I'm going to go ahead and zoom out. But we've got a good idea what's going on there. Most important thing, I cannot look at the negative values because the x values for this graph only works when x is greater than or equal to 0. So I'm going to modify my window just a little bit and start it at 0. So notice what's happening as I trace along. I know that as I move to the right that my y value is getting closer and closer and closer to 10. Which means, if I go back to my original question, as I get more and more to the right, or more and more time, my population of the insects is going to get closer and closer to 10 million.